So today we're going to talk about lesson 2.6, which is quadratic formula and the discriminant. Before we get into doing any solving, we're going to derive the quadratic formula and talk about where it comes from and how we develop the formula. And developing the formula was actually done using the completing the square method we learned about in this class. It would be Tuesday. So the first thing we need to identify is standard form of a quadratic. And standard form of a quadratic is known as ax squared plus bx plus c equals 0. So in order to use the quadratic formula, your quadratic needs to be in that format, okay? If your quadratic is not in this format, you cannot use the quadratic formula. So that's very important to make sure we're in this form before you try plugging anything into the quadratic formula. Now, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So how many people in here have seen this formula before? All right, hopefully everybody, because it is from Algebra 1, but I just want to make sure. So this is the quadratic formula, and the quadratic formula is useful because it can find solutions to any quadratic. The quadratic can be irrational, it can be imaginary. It doesn't matter what the solutions are, it will find the solutions to the quadratic no matter what. So that's why it's a really useful formula. So now we're going to talk about deriving the quadratic formula. So we're going to talk about how it basically came to be, as it's an equation. And we're going to talk about how it came to be by completing the square for the standard form of a quadratic. So like I said, I don't expect anybody in here to be able to completely do this on their own. I might ask you to reference a step or something like that from this table and kind of interpret it, but however, you're not going to be asked to do this completely on your own. So the first step is we're going to start with the standard form of a quadratic, which is ax squared plus bx plus c is equal to 0. And our goal for step 1 is to make sure that we're in standard form, and our standard form is equal to 0. So that's the first step. Now, what we're going to be doing is going through the steps of completing the square like we always do, but now we're going to be doing it with variables instead of numbers. So instead of numbers, we're going to be left with variable divided by another variable, okay? So it's going to look like there's a lot of variables going on. So don't be alarmed by that. So the next thing we always do when we complete the square is we need to get our c term to the other side, right? So we do what we always do when we complete the square. We subtract our c term to the other side, or add it, depending on what its sign is, and we leave space for that b term that we're going to create. So our goal here was to isolate c. Now from here, the next thing we always do is we check and see if our a term is 1. Now in this case, we don't know what our a term is. We just know it's a. So we're going to have to factor out that a, because it could be a number in any case. It could be a number that's not 1. So we're going to need to factor out the a. So I'm going to factor out the a on the left. So basically I divide everything by a. So b divided by a is just b over a, because we can't simplify that. Oh, I meant to write a. Why did I write a 2 there? Sorry. And then what we're going to do is we're going to try to get this a out of the way over here. So we're going to divide both sides by a. That cancels out my a over here, and I'm just left with this. All right? And because I'm not using the parentheses to hold anything anymore, we can just erase them. And everything goes away, and we're just left with this. Okay, so I basically just divided every term by a. So make the coefficient of x squared 1 divide everything by A. That was our goal on that step, which we did. So now our next step is going to be to actually complete the square. So we're going to have to create this term. So think back to completing the square when we learned about it 2 days ago. Does anybody remember what we do to this term? We take...
You divide it by 2.
You divide it by 2 and then you do what with it?
Square it.
Square it. Good. So we're going to divide b over a by 2 and then we're going to square it. Now I don't remember, I taught this in 4 different classes, so I don't remember which period I said this in or if I said them all of them. But whenever you divide a fraction by a number, a trick is to multiply the denominator by that number, and that's your new denominator. Okay? That's a trick when you divide a fraction by a number. Multiply your denominator by that number, and that's your new denominator. And then we have to square it, of course. So when we square that, it becomes, well, we don't need the parentheses anymore, b squared over 4a squared, because I squared the numerator and the denominator individually. Okay, everybody see where I got that from? So this step, all we did here was complete the square. We're going to complete the square here. So over here, I have to add that right here, right? That number I just came up with. So that's going to be plus b squared over 4a squared equals negative c over a. Now, can I just go adding things to one side of the equation? No. What do I have to do to balance it out? Good. I have to add it to the other side as well. And that's where we're at so far. So my next step is going to be to factor the trinomial and, that's an and sign, a poorly written one, simplify the right side. So let's go ahead and do that. So you know how, like, when we did completing the square, I was really focused on you understanding that whatever you get before you square your term is always going to be what goes in your binomial. Okay? That's always half of this number is going to be your two binomials. So this is going to be x plus b over 2a times x plus b over 2a. That's basically, if we were to factor this, is equal to. Now, we have to add these together. But in order to add two fractions, we need to make sure they have a what?
Oh, you're only factoring out the c value?
Yes, they have to have a common denominator. What were you saying?
Are you factoring out the c value?
No, I'm not going to factor anything out over here. I'm just going to combine these two fractions.
No, on the left, like you have 2 of the x plus b over 2a. Like, where did you get those 2 of them?
Okay, so if this were a normal quadratic, like x squared plus 4x plus 4, I would have to look for factors of this that add up to this, right? That would be these two. If you add these two together, okay, they add up to this, but you multiply them together, and they're this.
They add up to...
Correct. They add up to b over a. If you add, they have a common denominator. B plus b is 2b. 2b over 2a cancels out the a's, and I'm left with b over a. Now, because I don't expect you to do that every single time, especially with letters, the trick is, before you square this, you take whatever that is, and that's always going to be your two factors. Does that make sense? Okay. So that's where I got those from. I basically factored it as if it were any number. It's just kind of confusing because it's letters. So then on the right, I need to add those two fractions together. So I'm going to move over a little bit over here so I can do this work on the side, just so I have some room. So I'm going to try to add negative c over a plus b squared over 4a squared. So like we said, we need to get a common denominator, okay? So how can I get a to be 4a squared? What can I multiply a by? 4a. Good. We have to multiply the numerator and denominator of this fraction by 4a. And in doing so, I now will have a common denominator. And this is going to become negative 4ac over 4a squared plus b squared over 4a squared. So now we have a common denominator. So whenever you have a common denominator for fractions, it's going to become one big fraction, okay, with the denominator that you have in common, and you're going to add the numerator and denominator. Now in this case, I'm going to add it, and you could write it as negative 4ac plus b squared, but I'm going to write it backwards. I'm going to just flip those terms around, okay, and write it this way, which is still mathematically correct. And the reason for this is, are you starting to see how it resembles the quadratic formula? Okay, so we want it to resemble that quadratic formula. So now what I get right here is what I'm going to put right here, because that's my simplified version. So that's b squared minus 4ac all over 4a squared. All right, moving on. So now, how can I rewrite any two identical binomials? Good, squared. Now my next step is going to be, now do you guys remember what you do once you get it squared? You take the what of both sides? Square root. So we have to square root both sides. And when I take the square root of anything to the second power, what happens? Yeah, they cancel out and we're left with x plus b over 2a equals. Now over here, I can't take the square root of the numerator. There's nothing I can do with that, so I'm just going to leave it under a square root. However, looking at the denominator, can I take the square root of the denominator? What is it? Not 4a, you're right with the a part, but what's the square root of 4? 2a. So here we just canceled out, we just simplified basically. We canceled out the square roots. We just simplified everything. Wait, yeah, simplified. There's not an extra I in there. So from here, we know that the quadratic formula has x by itself on the left. So what can we do to get x by itself?
Minus b over 2a.
Good. Hang on. I forgot one thing. When we take the square root, we have to do plus or minus here. We forgot about that. That was my bad. So this has a plus or minus right here. Equals plus or minus. And you're right. Yes, we have to subtract b over 2a on both sides, right? So if we subtract b over 2a on both sides, that's going to leave me with x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And all we did here was subtract b over 2 on both sides. So we're literally one step from being the quadratic formula. As you can see here, they have a common denominator, so you can actually combine the numerator and the denominator. But before we do, or the numerator and leave the same denominator. However, before we do that, I want to talk about what these two individual pieces represent. So, does this piece look familiar to you from something else we've talked about?
It's axis of symmetry.
Yeah, axis of symmetry, vertex. It's the x-coordinate of your vertex or the axis of symmetry. Very good. So this represents the axis of symmetry, okay? And pretty much nothing in math is a coincidence, okay? There's a reason that that's part of the quadratic formula. So I'd like to take a second to explain how this has to do with the quadratic formula and how it helps us find solutions. So let's go over to our little graph over here so we can take a look. So think about how a quadratic looks for a second. So of course we have this axis of symmetry that goes down the middle, okay? And then we have our two solutions on the other on opposite sides, right? And what do you know to be true about the distance from each solution to the axis of symmetry? Yeah, they're the same. I'm going to use a little geometry notation here. Yes, they are congruent. Okay, these distances are the same for each of these. And basically, what you're doing when you use the quadratic formula is you're finding the equidistant points that are equidistant on both sides of the axis of symmetry, because they're always equidistant. So this line right here is x equals negative b over 2a, which is your axis of symmetry. And then each of these points is you take the axis of symmetry, and over here you're going to add this piece to it. And over here you're going to subtract this piece from it. So that's where the plus or minus comes in. Because as we know, distance is always positive, so we're looking at the distance on the left, the distance on the right. Distance is the same, but to find those two distances we add or subtract. So I'll zoom out in a second once you guys get this down. But what I just want to mention is we don't get the very last step in this chart, because all we do to get the quadratic formula from here is we have a common denominator, we write it over one big denominator, and then combine the numerators. And that would give you the final quadratic formula. So that's how quadratic formula works. That's where it comes from. And that's how we can actually find it. So if, for example, in this crazy situation where you don't remember the quadratic formula, you could try to derive it yourself from a standard form of a quadratic. Does anyone need more time on this slide before we move on to the next? What do you mean number 8? Like, oh, step number 8? Yeah, they're all up right now, so you can take a look at them. Continue. So now we're going to look at the discriminant, okay? So in order to use the discriminant, you need to have standard form of your quadratic, okay? And standard form of your quadratic is denoted as ax squared plus bx plus c is equal to 0. And you need to be in that form in order to use the discriminant, okay? Now, the actual formula for the discriminant is known as b squared is equal to negative 4ac. So what is the discriminant? Well, the discriminant is basically a tool we use to determine how many solutions the quadratic has and what type of solutions the quadratic has without actually doing the full quadratic formula if we're not trying to actually look for what those exact solutions are. So can anybody tell me what this looks like? Where have you seen this before? Yeah, it's in the quadratic formula. What part of the quadratic formula is it? Good, the part under the square root. So basically what this means is the portion of your quadratic formula that exists under your square root is the part that tells you how many solutions you have and if they are rational or irrational or imaginary. So let's go ahead and talk about the different scenarios and how you can tell what they are. All right. So if you have no real solutions to your quadratic, okay, two complex imaginary solutions, So those are when they have I in them. What's going to happen is when you go to compute your discriminant, so you do b squared minus 4ac, that number is going to come out to be less than 0. And how this looks in terms of your graph, okay, your graph is going to look one of two ways. Your graph is either going to be going upward on both sides and it's not going to hit the x-axis, or your graph is going to be going downward on both sides and also never hit the x-axis. So when this happens, your graph will never hit the x-axis, and that's what your graphs would look like. So now we'll move on to one real rational root. So if you calculate b squared minus 4ac, and the number you get is exactly 0. Okay, that means you have one real rational root. So how that looks in terms of your graph is you have a graph of a quadratic, and that quadratic is going to hit the x-axis exactly once, and the point that it hits the x-axis at will also be known as your vertex. So the solution is also your vertex. Now, if you do the quadratic formula and you have a one solution scenario, what's going to happen is you're going to get two solutions, but they're going to be identical. So you might get 4 and 4. So that would indicate one solution. So while you calculate it twice, it's still the same solution, it's 1. Now the next one we'll talk about is two real rational solutions. So two real rational solutions is when you have b squared minus 4ac, and that comes out to be greater than 0. That's the first condition of two real rational roots. Now the second condition for two real rational roots is that this right here is a perfect square. So if that number comes out to be something like 9 or 16 or 64, that's going to give you two real rational roots. And how this looks on your graph is this is going to hit the x-axis twice, and the points that it hits the x-axis at are going to be just regular whole numbers, okay, something like, or it could be a decimal, but something like -4 and 4, okay, it could be like 1/2, something that's rational, not a crazy decimal or a square root of something we can't fully calculate without a calculator. And the last one we're going to talk about is two real irrational roots. So the first condition is the same as two real rational roots. Your b squared minus 4ac number is still going to be greater than 0. But whatever you get right here is not going to be a perfect square. So that number is something like 21 or 19. Any number you know that is not a perfect square. And how that is going to look for your graph is your graph is going to look similar to the last one, but the difference is it's going to hit the x-axis at really weird values. So it's going to hit it at like something like negative square root of 2 and 2. Now these are square root of 2. These are just two examples I'm using. Okay, these are not always going to be your solutions. I'm just showing you two examples of what would be considered rational and irrational. You guys ready for the next part? No? No? Okay. I'll wait a second.
I just don't want to. No, I'm ready.
Oh, you are ready.
I just don't want to do it.
Oh, well, I can't help you with that one, unfortunately. All right.
Is it on the back?
Yep, right on the back, example 1. That's example 1 right there. For some reason, it printed without the the equations on it, so you just have to write them down. So for example 1, we are going to need to use the quadratic formula and the discriminant. So I want you to try to work smarter, not harder. If we're calculating the quadratic formula anyways, do we need to also do the discriminant formula separately? No, because it's part of it, right? So once we get to that step in the quadratic formula, we can just look at that part, okay? So what we need to do here is we need to make sure that we're in the form ax squared plus bx plus c. What do you guys think? Once we get that, we're going to identify a, b, and c. A is, b is, and c is. Good. So once we've identified a, b, and c, we're now going to plug it into the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I just plugged everything in, and now we're just going to calculate this. So this is going to become, oh, there's stuff down here, hang on. Thought I erased it all, but I missed this. So this is going to become x equals negative 25 plus or minus 625 minus, I don't remember. Did you get 264? Okay, that's what I got. 264 all over 4. Now we're going to calculate what's inside the square root. And remember, whatever's underneath the square root is also known as our discriminant. Okay? So we get x equals negative 25 plus or minus, and 625 minus 264 is equal to 361 all over 4. So this right here is our discriminant. Okay? Now oh, go ahead.
Why do we need to find the discriminant again?
The discriminant helps us determine what kind of roots we have, if they're real, rational. Now technically you'll see that at the end of the quadratic formula as well. I just want to show you where the discriminant is so you know. Oh, go ahead.
Oh, is it the whole top? Is that the discriminant, or is it just the square root?
The discriminant is only the portion underneath the square root, because that's where b squared minus 4ac is in the formula.
Oh, that's true.
Okay.
Yeah.
So off the top of my head, I did not know that this was a perfect square, but it is. It's actually 19. So you sometimes just have to check in your calculator, okay? Because some of them are not going to be like ones that you have memorized. It's going to be plus or minus 19 over 4. Now, is 19, where does that fall in the categories if we get discriminant equals 19? Which category is that? Look, if you look at your sheet. Yes, it's going to be 2 real rational roots. Technically speaking, your discriminant is actually 361, and that is a perfect square because we checked it, okay? So, that is going to be 2 real rational roots, okay?
How do you know if it's going to be 2 real rational?
Because my discriminant is greater than 0,
okay.
and it's also a perfect square.
Okay.
Okay, it fulfills the 2 requirements. So now, once you get to this step, we also want to find our x values. So you always are going to rewrite your 2 x values. You're going to rewrite it as negative 25 plus 19 over 4. And then you're also going to have negative 25 minus 19 over 4.
So in order to have 2 real solutions, it needs to be a perfect square.
They're still real, but in order to have 2 real and rational solutions. So you could get a real solution that's not rational. Like the square root of 2 is a real number. It's just not a rational number.
Mm-hmm.
Okay. So if I add these two, 19 minus 25, I get negative 6 over 4, which reduces to negative 3 over 2. And down here, I think it comes out to be, yeah, negative 44 over 4, which is negative 11. So how you write your 2 solutions is negative 3 over 2 comma 0 and negative 11 comma 0. And that will be your solutions. And to fill in your other blanks on your sheet, the number of solutions you have here, oops, why did I do that? The number of solutions is 2, okay, and the type of solutions is real rational. So those are your fill-ins. Does that make sense so far? Alright, for the sake of time, I want you to be able to have some time on the homework. So let's skip to example 4. We'll do that one first, because then if we run out of time, I want you to see one that's imaginary. So I'm going to go to example 4, and example 4 is this, so go ahead and write that down.
Wait, what was the type of solution? Rational?
Rational, it would be real/rational.
Okay.
And how do you determine what kind of solution it is again?
You look at the discriminant, which is the number that exists underneath your square root of your quadratic formula.
Okay.
And if you're not trying to do the quadratic formula, you would just do b squared minus 4ac from your quadratic. If that number comes out to be 1, you look at this for the classification. So if that number comes out to be less than 0, we know it's no real solutions. If it comes out to be exactly 0, it means we have one real rational root. And then that's how you look at this chart to determine what it is. That make sense?
Mm-hmm. So if it's equal to 0, then it's one real rational solution.
Correct. Alright, so for example 4, first thing we need to do is get it into the form ax squared plus bx plus c equals 0. So how can I do that here?
Add 13.
Good, we have to add 13 to both sides. That cancels out my 13 over here, and I'm left with x squared minus 4x plus 13 is equal to 0. Now that we have that, we can determine a, b, and c. So what's a? Good. B and c. Good. So now we're just going to plug this into the quadratic formula, and that's just going to be x equals negative b. Now if your b is already negative, it's going to become positive, okay? It just changes the sign, plus or minus the square root of b squared. Don't forget to square the whole thing if it's negative. Minus 4 times a times c all over 2 times a. So now I need to simplify what's inside the square root. So negative 4 squared is 16 minus 4 times 13, which is 52, all over 2. So this is x equals 4 plus or minus 16 minus 52 is actually negative 36, okay, over 2. Now this right here is your discriminant, okay? And we want to determine where this is classified. So which classification would this discriminant have according to your chart? Good, no real solutions. So what this also means is we have 2 complex imaginary solutions. So there's no real solutions, we're going to end up with 2 imaginary solutions, which makes sense.
Why is it no real solution? Yeah.
Because if you look at the chart on the front, it's if your discriminant comes out to be less than 0, and negative 36 is less than 0.
Oh, okay.
Okay. So this means we have no real solutions. We have 2 complex imaginary solutions. So we have to keep going with our solving, of course. So anybody remember how to take the square root of a negative number? We learned about it last week.
Yeah, you multiply it by negative 1 under the radical.
Yes, and that comes out.
Imaginary numbers.
Yes, that comes out to be I. So anytime you take the square root of a negative number, it's always whatever that square root of that regular number is, and then times I. So it's just 6i. So you throw that I in when it's the square root of a negative. All over 2. And then we have our two versions of our solution, of course. We have 4 plus 6i over 2. And we have 4 minus 6i over 2. Now, this is not the fully simplified version of our solution, okay? And that's because what can I factor out of the numerator of both of these? 2. So I can factor out a 2. And then what can I do with the numerator and denominator now? Yeah, the 2's cancel. So my simplified versions are x equals 2 plus 3i and x equals 2 minus 3i. So those would be your two solutions. Now, if you want to write these solutions in the form of a ordered pair, how this looks mathematically is it's just 2 plus 3i, comma 0, and 2 minus 3i, comma 0. Now we haven't learned this in this class yet, but there is a way to graph complex solutions. You just haven't learned that yet. So you wouldn't be able to graph this, but you would be able to find them so far. And then to fill in your other boxes for this question, the number of solutions are 2, and the type of solutions are imaginary, okay? So there's 2 solutions, and they're imaginary. Okay, so what I'm going to do now is I'm going to give you the other 2 examples. Alright, so go ahead and get 2 down.
Could you go back to that?
Oh, yeah, you need more time? Sure. Is this part of the screen good?
Yeah, that's fine.
Okay.
It would be 0 solutions, right? Or would you put 2 imaginary?
There's still 2 solutions, they're just not real solutions.
Okay.
So there's 2 solutions and the type is imaginary. Okay. You're welcome. So now I'm going to go back and just give you example 2 and example 3. So go ahead and get down example 2. Yeah, there was just an issue with the print, so sorry. I'm going to give you example 3. So that's example 3. Alright, everybody good with that? And then the next one I'm going to give you is all 8 of your homework problems, which didn't print. So you guys go ahead and get these problems down on your homework. And while you guys do that, I'm going to do the solutions to 2 and 3, and then you can check your work with me for the examples. So once you're done with those, you guys can just work on the problems. And then, like I said, I will give you the 2 examples, which I'm going to calculate right now. Alright, you guys ready to see example 2? Yes.
For some of the homework questions, if the A is like negative, B is like totally negative, or you just use it?
Yeah, so if the A is negative, when you go to use it in the formula, you're gonna it's gonna be negative 4 goes into the quadratic formula. Yep.
So just keep the negative?
Yep, you keep signs whenever they are, if you have a negative C or a negative A, you keep it. The only exception to that is with the B. You know how the beginning is negative B, it's always gonna change the sign of that B. So here I'm just gonna show you example 2 so you can see it.